Hey, welcome back to your favorite trig class. Today we're going to talk about trig equations, and so we're going to use our unit circle sheet quite a bit. And what the main strategy is when you're solving, like for example with this first one, you're trying to solve this such that for what values of x is this true? And notice they give us from 0, and I'm going to do this in radians, up to 2 pi, so they have that restriction. So I'm thinking to myself, well, the cosine of what is root 3 over 2? So I'm looking on my unit circle, and I'm like, oh, I've got a cosine right here that's root 3 over 2. So cosine of what angle is that? We know that's pi 6. So it could be, we know cosine pi 6 is root 3 over 2, right? So x could be pi 6. But we also know that's not the only one. We could also look on our unit circle, and you see that cosine of 11 pi sixths, or 330 degrees, is also root 3 over 2. So x here could be either of those. 30 degrees or 330 degrees would satisfy that. Okay. Now there's another way to go about this as well. Once this is isolated, note that we could undo the cosine with the arc cosine on both sides. And if we take the arc cosine of the cosine of x, we'd get x, and then we'd have the arc cosine of root 3 over 2. Well, this is just going to spit out, this will just spit out our pi 6. And that's because the original cosine was restricted. When we restricted the original cosine, we restricted it between 0 and pi. So it's only going to give us solutions between 0 and pi. It's not going to give us the 11 pi sixths as well. So that's the problem with going this route. That's why I don't like to go that way. Let's do some more here, solving trig functions. Negative 2 sine of x equals 1. We're going to go ahead and isolate the trig function. So we're going to divide both sides by negative 2. So we got the sine of x is negative a half. And then we look on our unit circle and we say, well, where do we have a sine that's negative a half? We have it in 2 spots. All right, we know the sine of, let's go to this first one. We know the sine of 7 pi 6 is negative a half. And we also know that the sine of 11 pi sixths, or 330 degrees, is also negative a half, right? The sine, again, this is saying the sine of what angle is negative a half, right? And we know the sine of 7 pi 6 is negative a half, right? We know the sine, write this, we know the sine 7 pi 6 is negative a half. So we know, and we also know this, so x could be 7 pi 6. And we know the sine 11 pi 6 is also negative a half. And that's just in the first period. Now there's more than just those answers. Notice this one, the last one had a restriction. It said just give us the answers between 0 and 2 pi. Including 0 up to 2 pi. This one, though, has no restrictions. So we got to go with all the possible solutions. So let's think about this 7 pi 6 for a minute. It could be 7 pi 6, but it could also go, I could go around, what's coterminal to that? Well, 7 pi 6 plus 2 pi. In other words, 19 pi 6. So if I go plus, I could summarize all possible solutions as 7 pi 6 plus 2 pi k, where my k is an integer. Okay, remember the integers are the set of all those numbers, right? The counting numbers, the whole numbers, and all the negatives of the natural numbers, right? So let's see if that works, okay? So for example, 7 pi 6 plus 2 pi, right? If I go around again like in green, well, that's 7 pi 6 plus 12 pi 6. That gives me 19 pi 6. And yeah, the sign of 19 pi 6 is negative a half. What if k, then that's if k is 1, right? If k is 1. Well, if we go around twice, let me erase the green. So let's say I go around twice. Oops. There's around once plus 7 pi 6, twice plus 7 pi 6. So that's if k is 2. So now that'd be 7 pi 6 plus 2 pi times 2. So 7 pi 6 plus 4 pi, 7 pi 6 plus 24 pi over 6, which is 31 pi over 6. That's also true, right? That's if k is 2. Now we can keep going with this. You know, if k is 0, then we just have 7 pi 6. If k is negative 1, that gives us 7 pi 6 minus 12 pi over 6. That gives us the negative 5 pi over 6, right, which is coterminal. The sinus negative 5 pi over 6 also has a sign that's negative a half, and so on. So that takes care of all forms, every one of those possible solutions. Okay, so here's one of our sets. And now let's do our other one. And let's do for this where we go 11 pi 6. So we know the sign of 11 pi 6. I'll do this in orange here. 11 pi 6 plus all 2 pi k, in other words, all coterminal angles there, all angles that end up at that spot, will give us the other set of solutions, because again, it's not restricted to just 0 to 2 pi. So this gives us every one of the possible solutions, right? For example, if k is 0, then we got 11 pi 6. If k is 1, let me erase this. K is 0. If k is 1, then we got 11 pi 6 plus 2 pi times 1. 11 pi 6 plus 12 pi over 6, so 23 pi over 6. And we could keep going, k being 2 and so on. We go in the other direction. If k is negative 1, then that would be 11 pi 6 plus 2 pi times negative 1. So 11 pi 6 minus 12 pi over 6 is negative pi over 6. Negative pi over 6. So that's this one right there. Again, we know the sign of negative pi over 6 is also negative a half. So these two right here give us all the solutions. Every solution is listed here for all real values of x. Okay. Now, most of the ones that we're going to do are going to be restricted. Like this one's also restricted from 0 to 2 pi. Oops. What's going on here? 0 to 2 pi, like I mentioned. Most of them are restricted. Let's go ahead and solve this one. So we're going to isolate the cosine, the trig function. So we'll subtract square root of 2 on both sides first. So we got 2 cosine x is negative root 2. Divide both sides by 2. So we got the cosine is negative root 2 over 2. So then we say to ourselves, well, cosine of what, right? Cosine of what angle on our unit circle is negative root 2 over 2. So I look on my unit circle. I find where I have a cosine that's a negative root 2 over 2. And it happens right there. So I know that's an answer. It also has another one over here that has a, in quadrant 3, that also has a cosine of negative root 2 over 2, right? So that first one would be 3 pi 4. So we know the cosine We know the cosine of 3 pi fourths is negative root 2 over 2. And then we also know that the cosine of 5 pi fourths, that's the green one, is also negative root 2 over 2. So those are our only solutions here. So 3 pi fourths and 5 pi fourths are the only ones that work because I'm restricted. I'm bound in that first period, right? I can only look between 0 and 2 pi. Okay. All right, this next one we got cosine squared. Well, let's undo the cosine. Notice it's already isolated, the cosine. Cosine is just squared. So we're going to square root both sides. Well, if I square root both sides, don't forget plus or minus on that. So I got plus or minus the square root at the top over the square root of 4, which is 2. And so we've got two here I got to think about. The cosine of what is root 3 over 2? And the cosine of what is negative root 3 over 2? So let's answer the first one there. Cosine of what is root 3 over 2? So I have two spots where that occurs on my unit circle. Right, first one would be pi sixths. So pi 6 would make this true. And I know 11 pi 6 is the other one. 11 pi, cosine of 11 pi 6 is also root 3 over 2. So there's two of our answers. Now let's go to this next one over here. Cosine of what is negative root 3 over 2? So now I'm looking for where do we have a cosine that is negative root 3 over 2. And so we know that happens right here at 5 pi 6. And at 7 pi 6. Cosine of 7 pi 6 is also negative root 3 over 2. Okay, so there's all our solutions. And of course, we'd write them all together. Pi 6, 5 pi 6, 7 pi 6, 11 pi 6. And that's all of them within that first period from 0 to 2 pi. Now let's take a look here at this 5 cosecant x minus 3 equals 2. We're going to isolate our cosecant, our trig function. So we're going to add 3 both sides. So we got 5 cosecant of x equals 5. Go ahead and divide both sides by that 5. So we get the cosecant of x equals 1. In other words, 1 over the sine equals 1. But we got to get the sine on the top. So we got 1 equals 1 times sine. So sine of x equals 1. So then we just say to ourselves, well, sine of what equals 1? We're only looking between 0 and 2 pi. And of course, that is right there at pi halves. We know the sine of pi halves is 1. On 0 to 2 pi. Another restricted domain here from 0 to 360 degrees or 0 to 2 pi. We've got 3 square root of 3 cotangent theta plus 1 equals 0. So let's go ahead and subtract 1 on both sides. Divide by square root of 3. So we get the cotangent of theta is negative 1 over root 3. In other words, 1 over the tangent is negative 1 over root 3. Let's get the tangent on the top. So we've got 1 equals negative 1 over root 3 tangent theta. Let's multiply both sides by negative root 3 over 1, that reciprocal. And so we get the tangent of theta equals negative root 3. So we know the sine. Let me come over here. sine over the cosine is negative root 3. And so we're looking, if you notice on our on our unit circle, if we can get the sine to be negative root 3 over 2 and our cosine to be a half, that would work. Or if the sine was root 3 over 2 and the cosine's negative a half, then that would also work, right? And so let's go ahead and look at our trig unit circle here. And you notice we have at 2 pi thirds. Pull this up a little bit. Oops, there we go. See how you have a sine over a cosine. So root 3 over 2 over negative a half. That would reduce to negative root 3, right? So it happens at 2 pi thirds. And it also happens at, our other one would be 5 pi thirds, right? If we go over to 5 pi thirds, then the sine there is negative root 3 over 2, and the cosine is positive a half. So that's also simplifies to negative root 3. So theta could be 5 pi thirds as well. So 2 pi thirds or 5 pi thirds. So 2 pi thirds and 5 pi thirds. And those are within 0 to 2 pi. Now let's do it with a double angle here. We got cosine of 2 theta equals a half. So I'm thinking to myself, and notice there's no restrictions. It's not like it's just from 0 to 2 pi. So cosine of what is a half? And we know, well, at pi thirds, right, 60 degrees, we have a cosine that's a half. So we know cosine of pi thirds is a half. We also know the cosine of 5 pi thirds is also a half, right? But notice we have 2 theta. So what we do is we say, and let's start with pi thirds for a minute. It could be pi thirds. It could also be pi thirds plus 2 pi. It could also be pi thirds plus 2 pi plus 2 pi, and so on. So the general form would be pi thirds plus any 2 pi k, where k again is an integer. If you remember our integers, negative 3, negative 2, negative 1, 0, 1, 2, 3. And that would hit any of these, erase any of these at pi thirds, right? Any coterminal angle. So it would also do negative 5 pi thirds if k is negative 1, and so on. This takes care of all of them, right? That hit right there at that spot. And so we know we don't have theta, we have cosine 2 theta. So we're going to set 2 theta equal to that general form for all answers right there at that pi thirds spot, right? And then we're going to take and divide everybody by 2. And so theta would be pi 6 plus pi k, where k is any integer, okay? There's one of our solutions. Now we also know 2 theta has got to be equal to 5 pi thirds, right? We also knew at 5 pi thirds, oops, let me erase that. We know at 5 pi thirds, we also have a cosine that's a half. And so we're going to go ahead and set, we're going to set 2 theta equal to 5 pi thirds. So here's all forms would be 5 pi thirds plus any 2 pi k, where k is an integer. And that hits any of these right here That'll hit any of those, right? If k is 0, it's 5 pi thirds. If k is -1, it'd be negative pi thirds. If k is 1, it'd be 5 pi thirds plus 2 pi, which is 11 pi thirds, and so on, right? So it takes care of all cases. Now we go ahead and divide everybody by 2. And so theta is 5 pi 6 plus pi k. Again, where k is any integer. And this takes care of these two, the black one and the orange one, take care of every solution for all k integers, k being an integer. Okay, and let's do some more here with another double angle. Sine of 2 theta. Sine of 2 theta equals -√3/2. And so I'm looking at my unit circle, and I want to know where my sine is -√3/2. So I'm like, oh, let's see, that'd be 2 pi thirds. I'm sorry, oops, I drew that wrong. Just kidding. My sine is negative. Good grief. There we go. 4 pi thirds would have a sine that's -√3/2. And so, since we know the sine of 4 pi thirds -√3/2, let's start with that one. So we're going to set 2 theta equal to 4 pi thirds plus any 2 pi k. And then we'll go ahead and divide everybody by 2. And so we get all forms of the solution here. So we got 4/2 gives us 2 pi thirds. So 2 pi thirds plus pi k. Now I know it's restricted here, so let's start plugging in k values to name them all. So let's if k is 0, then we just have 2 pi thirds. If k is 1, 2 pi thirds plus pi, or 3 pi thirds is pi, right? We got 5 pi thirds. Now notice 5 pi thirds is still within 0 to 2 pi, right? Now if we let k be 2, so we'll have 2 pi thirds plus 2 pi, or 2 pi thirds plus 6 pi over 3. That's 8 pi over 3. Well, that's outside. That's bigger than 2 pi, right? 8 pi over 3 is bigger than 2 pi, because 2 pi is 6 pi thirds. So that's too big. So we know these two are good to go. And I don't want to let k be like -1, because 2 pi thirds minus pi would be negative pi thirds. Again, not within 0 to 2 pi, right? All right, so now let's do the other spot where I know the sine is -√3/2. And that in green there, and that would be at 5 pi thirds. 5 pi thirds, so 300 degrees, right? So we're going to go ahead and we're going to let 2 theta, because we know sine of 5 pi thirds, we let 2 theta be that 5 pi thirds plus all 2 pi k. We're going to divide everybody by 2. So same approach here. We got 5 pi 6 plus pi k. And this will spit out all our answers. So let's let k be 0. Then it'd be 5 pi 6. If I let k be 1, 5 pi 6 plus 6 pi over 6. I let k be 2, then I'd have 5 pi 6 plus 2 pi, or 5 pi 6 plus 12 pi over 6. That's 17 pi over 6, but that's too big. 12 pi over 6 is 2 pi. That's too big. It's outside. So we just stop right there. So these 4 are our solutions that are within 0 to 2 pi, right? And that's because we had this double angle, right? Everything's cut in half, so it's more than just the 2 pi thirds and the 5 pi 6. You got to be careful on that and consider all angles, right? Because if your initial angle is more than 360, but then it's cut in half because it's divided by 2 for that 2 theta, then you've got these other ones, right? The 5 pi thirds, 11 pi 6, that you have to account for. All right, how about this one? 2 sine of theta over 2 minus 1 equals 0. Let's add 1. And then we'll divide by 2, So we got sine theta over 2 equals a half. And then we know that the sine of theta is a half at pi 6. So we know sine of pi 6 is a half. We also know over here at 5 pi 6 is the other spot. We know sine 5 pi 6 also is a half. And so let's go ahead and, so theta over 2 could be pi 6 plus any 2 pi k. And now this time we're going to multiply by 2. And so theta would be 2 pi over 6, which is pi over 3, plus 4 pi k. Again, everything's got to be between 0 and 2 pi. So let's let k be 0 and give us pi thirds. If I let k be 1, then I'd have pi thirds plus 4 pi times 1. Get a common denominator. So pi thirds plus 12 pi thirds, 13 pi thirds. Well, that's more than 2 pi. 2 pi is 6 pi thirds. That's too big. So we just stop right there with this one, right? If I let k be 2, it'd be way too big. If I let k be negative 1, it can't be negative, right? Now let's go to the next one here for the 5 pi 6, right? So theta over 2 equal to 5 pi 6 plus 2 pi k. Multiply everybody by 2. And so we got 10 pi over 6, or 5 pi thirds plus 4 pi k. That'll give me all solutions. Let's let k be 0. That'd be 5 pi thirds. Let k be 1. I'd have 5 pi thirds plus 4 pi. Get a common denominator. You have 5 pi thirds plus 12 pi over 3. That's 17 pi over 3. Again, that's more than 2 pi. 2 pi is 6 pi over 3. So I got to stop right there. So I just have these two answers, pi thirds and 5 pi thirds for this one. Now we're going to involve some factoring with some trig functions here, trig equations. Cosine squared minus cosine of x. Notice we can take a cosine of x out of each of those, and we'd be left with cosine x minus 1. Right? Notice if we distributed back, we'd have cosine squared minus cosine. And now we're to the zero product property, right? If a times b equals 0, then a equals 0 or b equals 0. So we go ahead and we take the cosine of x equals 0, we take the cosine of x minus 1 equals 0, and we solve each of these. And then we look on our unit circle. Where's the cosine of what equals 0? And we know that would be at pi halves at 90 degrees and 270 degrees. Again, we're only on 0 to 2 pi. And the cosine of what equals 1, and that would be 0. We also know at 2 pi it equals 1. The problem is 2 pi, though, we do not include 2 pi. You know, we have this parenthesis right here, so we can't include that. So we just stop there at 0. Just keep going here. This is quadratic in form as well. And so we'll factor 2 cosine squared plus cosine. So one of them's got to be a 2 cosine, the other one's got to be a cosine. And if you're struggling with this factoring, you know, maybe you want to let u be cosine of x. So you're just factoring 2u squared plus u minus 1. And so how would you factor that? I like to backwards FOIL. You know, I know factors of 2u squared, one's got to be 2u, one's got to be u. Factors of 1 is 1 and 1, and it's a negative 1, so one's got to be positive and one's got to be negative. I'd try that, and I'd FOIL it, see if it works. That didn't work. It's got to be a negative 1 and a plus 1, and so on, right? But you're just doing that with cosine, so let u be the cosine. So we got 2 cosine of x minus 1, cosine x plus 1. Again, if you're not sure if you factored it correctly, just make sure you FOIL it back and check it. 2 cosine squared plus 2 cosine of x minus 1 cosine of x minus 1. There's my like term, so I have 2 cosine squared x. 2 cosine minus 1 cosine is just a 1 cosine in the middle minus 1. You see how that's what we started with, right? So let me erase all this. So I did factor it correctly. And so now just use the zero product property. 2 cosine x minus 1 equals 0. Cosine x plus 1 equals 0. Cosine is negative 1. We know that happens at pi. Add 1, divide by 2, divide by 2. Cosine of what equals a half, and we know cosine of pi thirds is a half. We also know cosine of 5 pi thirds is a half. So here's all our answers for this one. Pi thirds, pi, 5 pi thirds are all within 0 to 2 pi on that. All right, this one, I got to get one side equals 0 in order to factor a sign out. So I have sine x cosine squared x minus 2 sine of x equals 0. Again, I can take a sign out, so I'd have cosine squared x minus 2 equals 0. And then I use the zero product property. I know the sine of x equals 0. Cosine squared x minus 2 equals 0. Where's the sine equal 0? That would happen at 0, pi, 2 pi. Again, 2 pi I cannot include because I'm going up to 360, but I'm not including that 2 pi. Cosine squared x minus 2, I'm going to isolate the cosine squared, so let's add 2 to both sides. Cosine squared x equals 2, and let's square root both sides. Cosine x equals plus or minus root 2 on that. And so now, if you think about this for a minute, you know, cosine is bounded, right? The cosine of something is bounded to be between, if you think about your cosine function for a minute, is between 1 and negative 1, right? Or if you're looking on your unit circle, right, the cosine's never more, cosine's never more than a value of 1, right? So you can do this a couple different ways. You can recognize that square root of 2 is not in the domain of the range of the cosine. In other words, it's not between negative 1 and 1, right? Square root of 2 is bigger than 1. It's like 1 point something, right? And it's the negative root 2 is negative 1 point something. Let's say it's negative 1.4 or something like that, okay? So it's outside this domain. So there's no solution to this. Another way you could do that, to see that, is when you take the arc cosine of this, and you punch that in, and same thing if for the other one, if you have negative root 2, and you punch in the arc cosine of negative root 2. Either way, if you punch that in to your graphing calculator, it'll tell you that's undefined. Let's go ahead and do that. Let me pull up decimals here. If we take the arc sine of square root of 2. See how it's undefined? Same thing if we'd have done the arcsine of negative root 2, also undefined. All right, so no solution from that one. Come back here, we'll flip over my device. And so these are no good. This doesn't help us. So it looks like all we got is 0 and pi for this one. And let's move on to the next one here where we have tangent cubed x minus tangent squared minus 3 tangent plus 3. And notice on this one I have 1, 2, 3, 4 terms. Oftentimes if you have 4 terms and you're using the approach of factoring, you're probably going to be factoring by grouping. And so if you look at the first two, see how I can take a tangent squared out of each of those? And I'd be left with tangent of x minus 1. And then if I look at the second two, see how I can take out a minus 3 on those? And so now I have these two terms, right? And notice I haven't changed anything. I just factored out tangent squared out of the first two, factored out a minus 3 on the next two. Again, if I distribute it back, I'd have the same thing. But each of these have a tangent x minus 1. So I'm going to take that whole term tangent x minus 1 out, and I'd be left with the tangent squared minus 3. And we just factored this thing by grouping. And notice if we FOILed all of this back, FOILed it out, we'd be left with the original function, right? And so at this point, we can go ahead and set each of these equal to 0. So tangent of x minus 1 equals 0. And tangent squared x minus 3 equals 0. So add 1 to both sides. Where's the tangent equal 1? So in other words, where's the sine over the cosine equal 1? Well, they got to be the same. So we know if the sine is root 2 over 2 and the cosine is root 2 over 2, that would be true. Where does that happen? At pi 4. So we know at 45 degrees that they're both the same. And then if you look in quadrant 3, at 5 pi fourths, the sine is the same as the cosine, right? And so it would give you 1 as well. So that happens at 5 pi fourths as well. So at 225 degrees. Okay, so we're done with that one. Now let's move over to this tangent squared minus x equals 3. Let's add 3 to both sides. So I have tangent squared x equals 3. Let's square root both sides. So the tangent of x is plus or minus root 3. And so where does the, let's think about where's the tangent equal positive root 3. Or let me, you know what, let me go over here for a minute. Tangent equal root 3. In other words, where's the sine over the cosine equal root 3? So we got to have our sine be, and then we'll also, by the way, have to do it for the negative root 3 as well. All right, let's do sine over cosine. So if we have root 3 over 2 being a sine, cosine be a half, notice that that will give us root 3. Okay, so where is the sine root 3 over 2 and the cosine a half? You say, oh, that's a pi thirds, right? So pi thirds, that happens. And if they're both negative, so down here, sine is negative root 3 over 2, cosine is negative a half. That'll work as well. So that would be at 4 pi thirds. Okay, that's where the tangent is positive root 3. Okay, so far we have these two answers, these two answers. Now let's do the one in orange here. Where's the tangent equal to negative root 3? Where's the sine over the cosine equal negative root 3? So we got to have negative root 3 over 2 over a half, or that positive and that being negative. So let's do where is it negative a half, the cosine and the sine being the positive root 3 over 2. So that would happen at 2 pi thirds. And now let's do where the sine is negative and the cosine's positive. So 1/2 negative root 3 over 2. And that happens at 5 pi thirds, or 300 degrees. Right? And there's all 6 of our solutions for this one. All right, about 3 more of these. We'll do some more with some factoring. We've got involving some replacements. Here we have 2 sine squared minus cosine of 2 theta equals 0. Now notice I'm in sines and cosines. So since I already have a sine squared of theta, sine of theta quantity squared, what I'm going to do is I'm going to make a replacement of the cosine of 2 theta. So I look at my double angle formulas. You know, cosine of 2 theta, there's actually 3 of those. If you look on your formula sheets, you could replace it with cosine squared minus sine squared, or 2 cosine squared, or 1 minus 2 sine squared theta. Well, since I already have thetas, right, what I'm going to do is I'm going to replace it with the one that's got thetas in. I'm going to use that double angle formula. So we have 2 sine squared theta minus, and I make that replacement right there, of 1 minus 2 sine squared theta. And this equals 0. So we have 2 sine squared theta minus 1 plus 2 sine squared theta equals 0. 2 sine squared plus 2 sine squared, 4 sine squared theta. Add 1, divide by 4, divide by 4, and now we square root. So the sine of theta is plus or minus, the square root of 1 is 1, square root of 4 is 2. So we have 2 equations here. Sine of theta is a half. So that happens, we know the sine of pi 6 is a half. We also know the sine of 5 pi 6 is a half. And then sine of theta is also negative a half, right? Where's the sine of theta negative a half? And that happens at 7 pi 6, or 210 degrees. And 11 pi 6, 330 degrees. And there's our 4 solutions for that one. Similarly, on this next one, we got sine of 2 theta equals cosine of theta, and I'm going to go ahead and take this cosine to the other side first. So we have sine of 2 theta minus cosine of theta. Again, I have a double angle formula for the sine of 2 theta. I have the double angle formula says the sine of 2u is 2 sine u cosine u, right? Don't forget that one. You see that one quite a bit. So the sine of 2 theta would be 2 sine theta cosine theta. And then we still got the minus cosine theta. Now we can factor cosine theta out of each of those. And we have 2 sine theta minus 1 equals 0. So we have cosine theta equals 0. And we have 2 sine theta minus 1 equals 0. Add 1, divide by 2, divide by 2. So sine of theta is a half. So that would be at pi 6 and 5 pi 6. And the cosine of theta equals 0. That would occur at 90 degrees, pi halves, and 270 degrees, 3 pi halves. And our last one here, we got 2 cotangent squared plus cosecant squared x minus 2 equals 0. So notice we have I either want to get everything in terms of cotangents or cosecants. And if you remember the Pythagorean identity, sine squared plus cosine squared equals 1. Do you remember the cotangent squared? So if I divided everything by sine squared, I'd have 1 plus cosine squared over sine squared. Cotangent squared is cosecant squared. And so cotangent squared is cosecant squared minus 1. So let's replace that with cosecant squared minus 1. So we got 2 cosecant squared x minus 1. And so we got 2 cosecant squared plus another cosecant squared. We got 3 of these cosecant squareds. Minus 2, so minus 4 equals 0. Let me add 4 to both sides. We divide by 3 on both sides. And remember, cosecant squared is 1 over sine squared. And so sine squared would be 3/4. Let me come up here. So then we got sine squared is 3/4. Square root. So the sine of x is plus or minus the square root of the top over the square root of the 4 is 2. So we have 2 equations here. The sine is the root positive root 3 over 2, or sine is negative root 3 over 2. Well, we know this happens. The sine of, we know pi thirds. Sine of pi thirds or 60 degrees is root 3 over 2. We also know sine of 2 pi thirds, 120 degrees, is also root 3 over 2. And we know this happens at 4 pi thirds or 240 degrees, and at 5 pi thirds. And there's all 4 of our solutions. I hope that kind of gets you started on solving trig equations. See you next time.